Elements are composed of atoms that have the same atomic number, that is, each atom has the same number of protons in its nucleus as all other atoms of that element. One example of an element is carbon. Carbon is an element with an atomic weight of 12.011 and an atomic number of 6. This is also the number of protons. More often than not, many elements have different versions of themselves due to the varying number of neutrons. These elements are known as isotopes. Isotopes are different atoms of the same element that have the same number of protons and electrons, but differ in the number of neutrons. Isotopes exhibit essentially identical chemical characteristics, but have different atomic masses. One isotope that many of us just know to be an element is carbon. Carbon has 3 different isotopes. These isotopes are known as carbon-12, carbon-13, and carbon-14. All of the isotopes belong to the exact same element, but have a different number of neutrons and also different atomic masses. The weighted average of the atomic mass for all isotopes of an element is the average atomic mass. The value is included on each periodic table below the element. Matter is defined as a substance that has mass and occupies space. What composes matter is what we all know as atoms. Atoms, by definition, are the smallest particles that exhibit chemical properties of an element. Everything that has volume and occupies space is composed of atoms. Atoms are composed of subatomic particles. These particles include protons, neutrons, electrons, and a nucleus. The neutron is the particle that has no charge, so therefore it is considered neutral. The proton is the particle that has a positive charge. Both the neutron and the proton compose almost all of the atomic weight or mass of the atom. They are also both located at the center, attached to the nucleus. Lastly is the electron. The electron has a negative charge and makes a very small contribution to the total mass of the atom, unlike the neutrons and protons. Electrons tend to float all around the nucleus in no specific pattern or pathway. But of course, atoms aren't always as simple when it comes to composing elements.
The periodic table is used to obtain the number of subatomic particles in an atom of a specific element. Luther Meyer, Dmitri Mendeleev, and Glenn Seaborg are the fathers of the periodic table. Mendeleev arranged the elements by atomic mass corresponding to relative molar mass. Symbols of the periodic table are chosen by an element's first letter or by first letter plus an additional letter of its English name. An example of this would be hydrogen with the symbol H and helium with the symbol He. Each row is named a period. Each element in the same period has the same amount of atomic orbitals. Each element that is in the first row has 1 orbital for its electrons. The elements in the second row have 2 orbitals for its electron and so on, but there's a maximum of 7 orbitals. Each column is called a group. Each element that is included in the same group has the same number of electrons in the outer orbital. These electrons are called valence electrons, which are the electrons that are involved in chemical bonds with other elements. Each element in the first column has 1 electron in its outer shell and so on. Elements are color labeled to depict metals, halogens, lanthanides, nonmetals, noble gases, and unknown elements. The first column of the periodic table are alkali metals. They are extremely reactive. Alkali metals tend to want to dump an electron and form a positive ion. This column is looking to hook up with an element on the opposite side of the periodic table. The second column consists of alkaline earth metals. These metals are still reactive but not as reactive as alkali metals. Columns 3 through 12 are transition metals. They are fairly unreactive. Columns 13 to 16 plus hydrogen are metals, metalloids, gases, and nonmetals. Column 17 are halogens, which are extremely reactive. Halogens love to react with alkali and alkaline earth metals, which are on the first column. The final column on the right are noble gases, which are completely unreactive. Row 8 in the periodic table are called lanthanides, are very reactive. The way that the periodic table is ordered helps to predict how it will behave. It is arranged by atomic number or order, which tells us how many protons there are in the element. The first shell can take 2 electrons, the second can take 8 electrons, as well as the third, and so on from there. Atomic number indicates the number of protons in an atom of the element and is located above its symbol in the periodic table. Atomic mass is the number of protons and neutrons in the atomic nucleus and reflects the heaviness of an element's atoms relative to atoms of other elements. Shown below, the element symbol and is rounded to the nearest whole number and designed by a subscript to the left. The number of protons equal the atomic number, and the number of neutrons is determined by subtracting the atomic number from the atomic mass. The number of electrons is determined indirectly by the atomic number. The number of the negatively charged electrons must equal the number of positively charged protons for an atom to be neutral. Atoms that have lost or gained electrons do not have the same number of protons and electrons and are referred to as ions. Any atom in the first column of the periodic table is expected to lose an electron to another atom. Those in the middle share electrons except for metals. Neutrons differ in isotopes, so in actuality, the average weight of an isotope and the normal atoms determine the atomic mass.